friends, in this session I explain frequent pattern growth algorithm, or we can say happy tree growth algorithm. A priori algorithm was explained in detail in our previous tutorial. In this session I will learn you about frequent pattern growth or FP growth in a method of mining frequent item sets. As we all know, a priori is an algorithm for frequent pattern mining that focuses on generating item sets and discovering the most frequent item set. It greatly reduces the size of the item set in the database. However, a priori has its own shortcomings as well. So here I discuss the shortcoming of a priori algorithm. The first shortcoming is using a priori needs a generation of candidate item sets. These item sets may be large in number if the item set in the database is huge. Second is a priori needs multiple scans of the database to check the support of each item set generated, and this leads to high costs. So these shortcomings can be overcome using the happy growth algorithm. So now I explain frequent pattern growth algorithm or happy growth algorithm. This algorithm is an improvement to the a priori method, or we can say a frequent pattern is generated without the need for candidate generation. Epigrowth algorithm represents the database in the form of a tree. So that's called a frequent pattern tree or epi tree. This tree structure will maintain the association between the item sets. The database is fragmented using one frequent item. This fragmented part is called pattern fragment. The item set of these fragmented patterns are analyzed. Thus, with this method, the search for frequent item set is reduced comparatively. So, this is the basic overview of the happy growth algorithm. Now, I explain about happy tree. A frequent pattern tree is a tree-like structure that is made with the initial item set of the database. Second one is the purpose of the happy tree is to mine the most frequent pattern. Each node of the happy tree represents an item of the item sets. The root node represents null, while the lower node represents the item sets. The association of the nodes with the lower nodes, that is the item set with the other item sets, are maintained while forming the tree. I explain frequent pattern algorithm steps, or we can say how we can generate a frequent pattern algorithms. The frequent pattern growth methods let us find the frequent pattern without candidate generations, or the alternate name of this algorithm is frequent pattern without candidate generation. So let us see the steps followed to mine the frequent pattern using frequent pattern growth algorithm. So in first step, we have find out the minimum support from the database or even example. In general, minimum support is given in digit, but if minimum support is given in percentage, then we have convert that support into digit with below equation. So equation is minimum support is equal to given minimum support means which is available in percentage into total transaction divided by 100. For example, support threshold is 50 percentage and total transaction is 6. So put this support threshold and total transaction into equation. So we have find out minimum support is 3. Now the next step is to scan the database to find the occurrence of the item sets in the database. This step is the same as the second step of a priori. The count of one item set in the database is called support count or frequency of one item sets. Now, in the next step is prioritize the items, or we can say priority to give the items. Means we have give the priority of each item according to its frequency of occurrence. At the same time, you have opportunity to drop the items which not fulfill the minimum support requirements. The dropping of item is based on your personal decision. So if you not remove that item, then further you can remove it. So now in next step is order the items table according to priority. Means we can order items column in that all the items are queued according to its priority, which mentioned in the earlier step. Now, the next step is to construct the FP tree. For this, create the root of the tree. The root is represented by null. The next step is to scan the database again and examine the transactions. Examine the first transaction and find out the item set in it. The item set with the maximum count is taken at the top. The next item set with lower count and so on. It means that the branch of the tree is constructed with transaction item set in descending order of count. Then the next transaction in the database is examined. The item sets are ordered in descending order of count. If any item set of this transaction is already present in another branch, for example, in the first transactions, then this transaction branch would share a common prefix to the root. This means that the common item set is linked to the new node of another item set in these transactions. Also, the count of the item set is increment as it occurs in the transactions. Both the common node and new node count is increment by 1 as they are created and linked according to transactions. Now, the next step is mine the created happy tree. For this, the lowest node is examined first, along with the links of the lowest node. The lowest node represents the frequency pattern length. For this, traverse the path in the happy tree. This path or paths are called a conditional pattern base. Conditional pattern base is a sub-database consisting of prefix path in the happy tree occurring with the lowest node, or we can say suffix. The next step is construct a conditional happy tree, which is formed by a count of item sets in the path. The item sets meets the threshold support are considered in the conditional happy tree. The next step is frequent pattern are generated from the conditional happy tree. So this way the happy tree algorithms are work. Now I explain this happy tree algorithm with numeric example of happy growth algorithm. See in table, we have 8 transactions. Like in transaction T1, we have E, A, D, B items. In transaction T2, we have D, A, C, E, B items. In transaction T3, we have C, A, B, E items. In transaction T4, we have B, A, D items. In transaction T5, we have only one item and it's D. In transaction T6, we have two items like D and E. In transaction T7, we have three items like A, D, and E. In transaction 8, we have two items like B and C. For this example, support threshold is given like 40 percentage and confidence is equal to 60 percentage. In step 2 is to scan the database to find the occurrence of the item sets in the database. Now, based on the given table, we have find out individual items, which their counts like A occurs 5 times in these transactions. Like A occurs T1 transactions, T2 transactions, T3 transactions, T4 transactions, and T7 transactions. Like B occurs 6 times. B occurs 6 times, like T1 transactions, T2 transactions, T3 transaction, T4 transactions, T6 transactions, and T8 transactions. Similarly, C occurs 3 times, D occurs 6 times, and E occurs 4 times. Now, in next step, we have prioritize the items. The items means based on the original table, we have find out the individual items and their counts like A occurs 5 times, B occurs 6 times, C occurs 3 times, D occurs 6 times, and E occurs 4 times. Now we have sort the items in descending order. So it's looked like B occurs 6 times, D occurs 6 times, A occurs 5 times, E occurs 4 times, C occurs 3 times. So our first item is B, then we have considered D, then we have considered A, then we have considered E, and last is C. Now, the next step is order the items table according to priority. Means we can order item columns. All the items are queued according to its priority, which mentioned in the earlier steps. So, final table according to priority is looks like in transaction T1 first occurs B, then D, then A, then E. In transaction T2 first occurs B, then D, then A, then E, then C. In transaction T3 first occurs B item, then A, then E, then C. In transaction T4 first occurs B, then D, then A. In transaction T5 first occurs B. In transaction T6 first occurs B, then D. In transaction T7 first occurs D, then A, then E. In transaction T8 first occurs B, then C. Now I explain combination of our step number 5 and 6 for build FP tree. Now see our original table. Based on that, we have create a FP tree. For that, first transactions, we have considered the root node null. Note that all the FP tree have null node as the root node. So draw the root node first and attach the items of row 1. Means row 1 include items like B, D, A and E. We can include these items one by one respectively, like in figure, and write their occurrence in front of it. Then, in second steps, we have update this figure by entering the items of row 2. Means row 2 includes, or we can say transaction T2 includes B, D, A, E, C items. Now, then without creating another branch, you can go through the previous branch up to E, and then you have create a new node after that of C. This case same as the scenario of the traveling through a road to visit the towns of the country. You should go through the same road to achieve another town near to the particular town. When you going through the branch second time, you should erase 1 and write 2 for indicating the 2 times you visit to that nodes. If you visit through 3 times, then write 3 after erase 2. So see in the figure the FP tree after adding row 1 and row 2, or we can say transaction 1 and 2. Now we have see our third transactions. In third transaction, we have B, A, E and C items. So you may think you can follow the same branch again by replacing the value of B, A, E and C. But you can't do that. You have opportunity to come through the B, but can't connect B to existing A, overtaking D. As a result, you should draw another A and connect it to B, and then connect new E to that A and new C to new E, like in figure. Now we have see our fourth row, or we can say fourth transactions that includes B, D and A items. Now we can just rename the frequency of occurrence in the existing branch. So B occurs 4 times, D occurs 3 times, E occurs 3 times, because this pattern is similar like transaction 1, or we can say transaction 2. In transaction T1, the first item is B, then D, then A, then E. In T2 transaction, first item is B, then D, then A, then E, then C. In T4 transactions, the first item is B, then D, then A. So in three transactions like T1, T2, and T4, first three item is same. So we can follow our first transaction of T1 path. Now, in fifth row, or we can say fifth transactions, we have only one item like D. Now we have opportunity to draw a new branch from null node like seen figure, and we have give that occurrence of D. So D occurs first time. Now we have see our next transactions or next row, or we can say our six transactions. In that we have two items like B and D. So B and D appears in this transaction. So just change the B is occurs 4 to 5, means first in up to fifth transactions B occurs 4 times. Now in sixth transaction B occurs fifth time and D occurs 4 times. Now in our seventh transactions we have attached two new node A and E to the D node, which hanging on the null node. Then mark D, A, E as D occurs 2 times, A occurs 1 times, and E occurs 1 times. Now, in our eighth transaction, we have attached a new node C to B. Now, change the travels time. B occurs 6 times and C occurs 1 time. So this way we have generate our FP tree. So I hope you can understand how to draw a FP tree. Now I explain step 7 to 9, means a construct a conditional FP tree and find frequent pattern are generated from the conditional FP tree. Now see the final FP tree, which include all the transactions. Now see the lowest node items and it C. So C is occurs in three branch like B, A, E and C. Second is B, D, A, E and C. And third is B and C. Therefore, the considering C as suffix, the prefix path will be B, A, E, and their count is 1. Then B, D, A, E, and their count is 1. Then B, and their count is 1. Means in three branch, C count is 1. So this forms the conditional pattern base. So our answer is B 3 because only one items cross the minimum supports. So we have only include those items in conditional happy tree which support is equal to or greater than the minimum support. So this path will generate all the combination of frequent patterns. So frequent pattern is B, comma C and occurrence of the B means 3. So our pattern, frequent pattern is B, comma C gem, their count and their count is 3. Now see the next lower node is E. E occurs 3 branches like B, A, E, B, D, A, E, and third is B, A, and E. Therefore, considering E as suffix and the prefix path will be B, A, and occurrence of E means one time. Then in second branch, B, D, A, gem 2 means in this branch the E occurs 2 times. And in third transactions, B, A, gem 1 means in this branch E occurs 1 time. So this forms the conditional pattern base. So answer is B gem 3, comma A gem 3, comma D gem 2. So this path will generate all combination of frequent pattern. So frequent pattern is B comma E gem 3, A comma E gem 3 and D comma E gem 2. Now see the lowest node, that item is A. So A is occurs 3 branches like B comma A, B comma D and third branch is D comma A. So therefore considering A as suffix, the prefix path will be B gem 1, B comma D gem 3, D gem 1. This forms the conditional pattern base. So answer is B gem 4 and B gem 3. So this path will generate all the combination of frequent patterns. So frequent patterns is B comma A gem 4 and B comma A gem 3. Now see the lowest node is D. So D is occurs in one branch like B comma D and therefore considering D as suffix, the prefix path will be B gem 4. So this forms the conditional pattern base. So answer is B gem 4. So this path will generate all the combination of frequent patterns. So frequent pattern is B comma D gem 4. So I hope you can understand the frequent pattern growth algorithm. Thank you friends watching this video. I hope you can understand how frequent pattern growth algorithm work. Thank you.